All right, people, brace yourself because it's getting rowdy. We are going to look at the applications of derivatives and beyond. Okay, so we know how to take derivatives. Now, we got that. We get power rule, we get chain, we can use product and quotient, and that's just dandy. Now, real quick, let's go back to this. So we have a graph. I don't know, it looks like this. And let's be clear here. There's tangent lines, and we like to look at the slope of these tangent lines, right? Like this, for example, is a negative slope, right? So the slope is negative and the graph itself is decreasing, right? The graph is going down because it's decreasing. But over here, we have a positive slope. A positive slope on this tangent line, and the graph itself is increasing. So that's all good. And that decreasing to increasing changed right about here, where in grade 11 we called that a vertex. So that represented where it was changing. And here's my point. What is the slope doing at that vertex? Isn't the slope actually 0? The slope is 0. So there's that. And that can happen at any vertex, if it's like a mountaintop vertex or valley vertex. So vertex is going to get a new name, and we're going to refer to vertexes as either max or minimums now, and they have a slope of 0. So that's fun. This is good. Okay, so this is good. Okay, and then the other thing that we know, but we don't ever talk about, is that what happens way over on this side of the graph? Where's our x value going? It's going from 1 to 2 to 3 to 5,000 to infinity. And then over on this side of the graph, where are we headed this way? We're headed to negative infinity. Okay, so this is what we're going to look at. We are going to look at the correlation between negative slope and a decreasing function. And we're going to look at the correlation between positive slope and an increasing function. We are going to eliminate the word vertex from our vocabulary, and we're going to recognize that a maximum or a minimum has a slope of 0. So this is what we know. We can see it on this graph. It makes sense. So now what we're going to do is figure out how we can find that, algebraically and without a graph. And if we can do that, then we're in business. Now, there's another thing I want to point out to you. Where's my graph? Okay, here's my graph again. So don't forget that max and mins can happen. You can have a max and a min in one function. So that's why we don't call them vertexes, right? So like this, for example, is a max, and this is a minimum, right? And if you looked at this right now and said, hey, can you highlight the part of this graph that is increasing, you would know that this part is increasing, right? And why do you know that that's increasing? You know that this is increasing because it's going up. It has a positive slope, right? And if I said, hey, where's it decreasing? You would say, well, it's decreasing here and it's decreasing here. Because remember, we read a graph from left to right. So this is a negative slope, right? Which is making this graph a decreasing graph. And same over here, negative slope. So this is a decreasing graph. Okay, so slope, we have determined, comes from derivatives, right? Slope comes from derivatives, and increasing and decreasing has to do with that slope, all right? So it all makes sense on a graph. But what happens if we look at this algebraically? So that's where we're going with this, but let's just real quick write some stuff down. So if we have a graph that is increasing, okay, the graph is going up in some way, shape, or form. So if our function, if our f of x is increasing, then the derivative of it must have what type of slope? It must have a positive slope, right? Isn't that what we just saw here? That if it's increasing, the slope is positive. And where do we find slope? We find slope in the derivative. So the same goes for negative slope. If we've got a decreasing function, then our slope must be negative, and slope comes from derivatives, and our derivative is our f prime. Now, what if we're talking about where the function is 0? Where do we find our max and mins? They're going to happen, sorry, I should draw that in red. They're going to happen when slope is 0. So max and mins happen when the slope, which comes from the derivative, is 0. So this is muy importante. Screenshot this, copy this down, do something with it. All right, so let's dive in. Let's try one. So our question is going to be, where is the interval? Interval's our new best friend. That's our new favorite word. Where is the interval that this function is increasing? Okay, so there's a couple keywords here. Interval means we're looking for a range. And increasing means what? What does increasing mean? We just decided that increasing means that the derivative, the slope, is positive. So therefore, where is our derivative going to give us positive numbers? So let's look at our function. Our function is f of x equals x squared minus 4x plus 1. So this is my original function. My original function is extremely useful. It'll tell me about x-intercepts, it'll tell me about y-intercepts, it'll give me coordinates. But I want to know where it's increasing, where is it going up? So to do that, I'm going to find my derivative, which is 2x minus 4. And I want to know where it's increasing. Well, it's quadratic, so it's increasing in some places and decreasing in other places. So I need to know where that changes. So to do that, I need to know where it's 0. So I'm going to take this and I'm going to set my 2x minus 4 equal to 0. And when I do that, I'm going to get 4 equals 2x, so x equals 2. So this is going to represent a maximum or a minimum. That has one more fancy name. Sorry to keep throwing all these fancy names at you. And because it's going to be an important place, we're going to call this a critical point. A critical point. There's lots of types of critical points. Maxes and mins are one of those. So I know that when x is 2, I know that my graph is changing directions. So I'm going to draw myself what I call a sign chart. So this little sign chart's basically like a little an x-axis. And I'm going to put that 2 on my sign chart. And I know that on either side of this 2, it's going to be positive. It's going to be increasing on one side and decreasing on the other, because this 2 is like my vertex, right? It's going to change. So I'm going to pick test points on both sides. I'm going to pick a number higher and I'm going to pick a number lower. So I'm going to pick 1 and 4. And I'm going to plug them in to my derivative, not to my original function. That would give me a coordinate. I don't want a coordinate. I want to know about slope. So if I plug in 4, if I say 2 times 4 minus 4, I get 8 minus 4 is 4. And that is a positive number. So therefore, my function is increasing on this side. And if I plug that 1 in into my derivative, I'm going to get 2 times 1 minus 4. So 2 minus 4 is negative 2. So this is a negative number. I don't actually care what the number is. I just need to know if it gives me a positive or negative, because that's my slope, right? Am I getting a positive slope or a negative slope? So what this tells me, let me make this a little bit smaller and get myself some more room. What this means is that on the graph at 2, here's my 2. This graph is increasing after 2. It's going up. And coming into 2, it's negative. It's decreasing, right? So remember what we said. We said that this is infinity over here and this is negative infinity. And our original question was, where is the interval that this function is increasing? Well, we can see that this function is increasing from 2 to infinity. It's increasing. And this is not a coordinate. This is interval notation. Interval notation. And that is the final answer. Let me remind you what we just did. We said, what interval is this function increasing? An increasing function means increasing slope. So we took our original function. We found its derivative. We set the derivative equal to 0. And that number gave us our max or min. We don't know if it's a max or min yet. That's why we just referred to it as max min. And that's a critical point. That means that things are happening there. Then we picked test points on either side of our critical point, of our max or min. We plugged the test points in to the derivative. We got positive numbers. We got 4, which is positive, which means the function is increasing. Over here, we plugged 1 into our derivative. We got a negative number, which means any number I plug in over here will produce a negative number because the slope is negative, therefore the function is decreasing. That makes sense. This is a decreasing function. That means any number over here that you plug in will be negative, will give you a negative slope because the slope is negative as you come into the vertex. Over here it'll be positive. Okay, let's try another one. Let's really kind of go for broke here. Here's our function. We're going to start with f of x equals x squared minus 8x plus 7. We're going to find the y-intercept, the x-intercept. We want to know the max and min. And we want to know the increasing and decreasing intervals. So we've got Lots to find, 4 things to find. Okay, our original function is extremely useful. Our original function is going to tell us, here's our y-intercept and our x-intercept. We're going to find that like we've always found it. We're going to find our derivative. The derivative is, the derivative, f prime, is 2x minus 8. So our derivative does what? What do we know our derivative can tell us about? It can help us find our max and min. And then now we know that it can also help us find our increasing and decreasing intervals. You have to go to the right place to find the right information. So it's extremely important that we remember that the original function only gives us coordinates and intercepts. All right, so our y-intercept right off the bat, boom. Where's my y-intercept? It's at, that's right, 7. 0, 7. I did no math to figure that out. Your x-intercept, well, where are we going to find that? Our x-intercept we need to factor, right? So we're going to say y equals x minus 7 times x minus 1. So our x-intercepts are going to be at 7 and 1. Okay, I'm going to erase that because I feel like we don't really need that. Okay, boom, look, we're already halfway done. All right, your max and your min, they are coming from your derivative. Maximums and minimums happen when the slope is 0. So we're going to take your derivative and make it equal to 0. So we're going to have 2x equals 8, x equals 4. So our max and min is occurring when x equals 4. Now, this is tricky. This is happening at x equals 4. Right now, that's enough information. However, if you want to know the y for that, if you decide you need to find the y value for that, where do you find y values? Where do you find coordinates? You find them in the original function. So you would have to plug that in. So you'd have 16 minus 32, negative 16 plus 7. So what's that, negative 9? Right? Gee, I hope I can do mental math. Okay, so the x, that's tricky. So the x came from the derivative, but the y came from the original function. Okay, increasing and decreasing intervals. We're going to draw our sign chart. And this time I'm going to put a 4 here because my critical point, my max or min, is 4. I'm going to pick 2 test points on either side. So let's pick 5 and let's pick 0 because that's easy. So if I plug in 0 to my derivative, I'm going to have 2 times 0 minus 8, which is negative 8. So this is a negative number. I don't actually even care what the number is. I just care that it's negative. On the other side, you can't always assume that because it's negative on one side, it'll be positive on the other side. That's not always the case. So we're going to, again, plug that into the derivative. So 2 times 5 minus 8 is a positive number. I don't care what that number is. I just need to know if it's negative or positive. So therefore, the increasing interval is from 4, I use round brackets, 4 to infinity, and the decreasing is from negative infinity. Wow, that's sideways. Negative infinity to 4. And that's your answer. The reason you can draw this with round brackets is because the question is specifically asking you for an interval, so we know that that's not a coordinate. Okay, that's it, you're done. Good job.